The diagram above shows part of the curve C with the equation y equals 9 minus 2x minus 2 over root x, where x is greater than 0. The point A, 1, 5, lies on the curve, and the curve crosses the x-axis at point B, B, 0, where B is a constant and greater than 0. Part A asks me to verify that B is equal to 4. So it's asking me to show that this coordinate here is 4. Well, if the x-coordinate there is 4, then the y-coordinate there is going to equal 0 because it intercepts on the x-axis. So all I need to do is show that when I substitute 4 into this function, I get the y-coordinate equaling 0. So let's do that. 9 minus 2 lots of 4 minus 2 over the square root of 4. So 9 minus 8 minus 2 over 2, which is equal to 0. Therefore, yes, B is 4. So that's part A of the question. We're then told that the tangent to the curve C at the point A cuts the x-axis at point D, as shown in the diagram above. We've got the tangent here cutting the x-axis at point D. We need to show the equation of the tangent to C at A is y plus x is equal to 6. So tangent is a straight line, y equals mx plus c, where the gradient is the same as the gradient of the curve. So I need to work out the gradient of the curve at point A. I can do that by differentiating to get the gradient function. But before I do any differentiation, I'm going to have to rewrite this in a form where it can be differentiated. The 9 and the minus 2x is easy to differentiate, but I don't like this root x on the bottom there. So I'm going to rewrite this. I'm going to move that root x to the top with a negative power. So we will have the minus 2 to the times x to the power minus a half. Now we can differentiate this. The 9 will differentiate to be 0. The minus 2x will differentiate to be minus 2. And then we're going to have minus a half times the minus 2, which is plus 1. Then take 1 away from this power. So minus a half minus 1 is minus 3 over 2. So this is my gradient function. At point A, where x equals 1, the gradient of the curve then, substituting 1 into this function, is minus 1. So the gradient of the curve at that point is minus 1. So therefore the gradient of the tangent will also be minus 1. And so I can say y equals minus x plus c. Substitute the coordinate in there. And so I find that c is 6. And so I can say y equals minus x plus 6. Or rearranging, adding x to both sides. I could write it like that, which is what we needed to show. Part C says to find the coordinates of point D. Point D is where that tangent, where the y plus x equals 6, it's where that tangent intersects on the x-axis, so where y equals 0. So if I make y 0, I find that x is 6 at that point. And then finally, we are told that the shaded region R, as shown in the diagram above, is bounded by the curve. So we've got the curve underneath here. The line AD, so this line AD, and the x-axis from B to D. we need to use integration to find the area of R. The way I'm going to do this is I'm going to integrate between 1 and 4, and that's going to tell me the area enclosed underneath the curve between the curve and the x-axis here. I'm then going to work out the area of this big right angle triangle, and if I do the triangle take away the red area, that will leave me with the shaded area here that I needed to find. So let's do that. Let's integrate our 9 minus 2x minus 2x to the power of minus a half, that original function, between the points of 1 and 4. So 9 is going to integrate to be 9x. The minus 2x will integrate to be minus x squared. And the next one, I'm going to show my working for this because this is a little bit trickier. Add 1 to the power. So the minus a half plus 1 is plus a half. And then we're going to divide by that new power, so dividing by a half. 2 divided by a half is 4. So we've integrated. We're now going to substitute the limits into this then. So we'll get 9 times 4 minus 4 squared minus 4 lots of 4 to the power of a half. Then substitute the lower limit, substitute 1 into this. And all of that gives me an area of 8. So the red area underneath here has an area of 8. I now want to do the big triangle. So that is all of this here. Now the height of the triangle is, well, that's just the y coordinate of point A, which is 5. The base of the triangle is all the way from 1 up to 6, which is 5. So therefore the area of this triangle is half base times height, which is 12.5. Therefore the shaded region R is going to be the triangle 12.5 minus the area underneath the curve, which was 8, which is 4.5.